We are going to discuss about aging. Of course, you are not interested in aging yet, but if you are lucky, you'll be older and older, and you want to figure out what will be the key that you can solve us, little bit slowing down your aging process. And you have to find the beauty of every year that you do have later on. All right, so there are some pictures. These are Tolstoy, for example, when he was a young one, and he was right before he died. So, of course, you can see the difference between a young one and an elderly people. Now, before we move on, I shall show you another movie that a little bit speeds up this process. This took about, let's see, 60 seconds or less when this guy aged very fast. Of course, we have much more time to do that one. So, what is the problem with aging? If you look at the distribution of, let's say, the age of the patient or the age of the man who lives in the world, you do see that by increasing. So look back in 1920s. When you look at the percentage of the elderly people, it was very low relatively. But by age, when it's getting closer to days, relatively on the world, everybody is getting a little bit more and more aged. And not only this, but if you look at the percentage of the very old people, relatively increasing further. Now, if you go back in early 19, the average lifespan wasn't longer than, let's say, 35 or 40 or so. Today, we are reaching around 70, 73, and some countries, the expected lifespan is around 80 years, almost 80 years. For example, in the United States, more person is over 65 than under 25 years is today. And the median average of the years is about, in 1995 was about 32, but in 2000 was in 36, and it's expected to be around 42 by the age of 2040. So, and very similarly, if you look at, let's say, the number of the people that's over 65, as you see by age, it increases tremendously, and the number, the absolute number, increases very much, and the percentage can reach about 20% or so. Now, why is so important, and why can be, let's say, the problem with this aging process? First of all, if you look at, let's see, the health care, how much it costs for an elderly people, usually they use up more than 30% of the healthcare resources. And this, if we continue to expecting that maybe in 2030 and 2040, the percentage of these people, it increases, so that can go up to 50% or so. And because elderly people usually require more social services and specialized recreation facilities, these require more money. It means more taxes. And the taxes should be paid by the younger one who works. So, and this is why the younger generation should somehow supply the money or supply the financial support for these elderly people. Now, if we want to summarize, or I want to give you some aspect, how old, or who is the oldest man on the world, aging processes, we do talk about the chronologic age. The chronologic age that you already have a document, you were born, and of course you can count the days, you can count months and ages. These are the chronologic age. But you know that some people look younger, some people look older. So these are called the biologic age. The biologic age could be determined based on, for example, the mitochondrial DNA damage. Because when we were born, after that, the oxidation and the metabolic processes usually altering the intracellular organs, and this can be measured. Very similarly, for example, the beta-galactosidase amount, that for example from the skin biopsy, It can show you relatively how the patient aging. Or glycosylation product, unless you do have a diseases that usually accelerate the glycosylation, but of course a diabetic patient usually aging faster than another one. Or by looking at or in the vision of the patient, because usually the patient is getting age and age, usually the arm is getting shorter and shorter, and you have the presbyopia. Rate of DNA unrounding, another one, or vital capacity and respiratory function. It can be measured and can be tested, let's say, the aging. Now, if you want to talk about the aging, we have to have different, let's say, category of the aging. We call the middle-aged person up to almost 60 years. So you should not say that is an old one if somebody is 50s, so he's still in the middle age, all right. Now, elderly one, we call elderly when the age is between 60 and 74, and old one we call over 75 to 90, and very old one that usually we call over 90. So these are the categories that WHO had. Now, the aging process, what is the general effect of the aging process? Usually, that's a universal sign that influencing every species, progressively going on, and you cannot stop it. You cannot do anything about it, because somehow it's internally coded into your body. Another one is beginning at maturity and ends with death. Normally, in man or human, this aging process is started around the age of 40. This is when you reach the plateau, and after you decline and slowly declines by the end. Or of course the viability of the body decreases, and as I said, this is internal causes that can of course have some genetic factors, and you do have some environmental factors. We shall talk about what are the percentage of these factors and how can you do something about this. Now, what this normal biological aging means? The biological aging primary is a reduction of the capability to adapt to changes in the environment. What does it mean? Relatively, when you live day to day, you have to accommodate to the surrounding the environment, and if you are aging, you have less and less chance. This is why an elderly patient usually suffering from more accident, and they're suffering from more other trauma from outside, because it's very difficult them to visualize and maybe to hear and to act right away to the other influences. Now, because this capacity is reduced, the organism becomes ever greater, promote the disease and the damage, and this is why the elderly people usually, they do have more diseases. If you look at this different function of a man, you see that, for example, the nerve conductivity that decreases, let's see, between 60 and 80, this age, but almost 8% only. The cardiac index decreases to 70%. Kidney function slowly after 40 years going down to 60s. Renal plasma flow decreases. Vital capacity decreases, and the breathing capacity decreases to 40%. So every function, every organ function decreases. Now, what can we say the basic changes of the aging processes? In elderly people, usually, they do have less water and more fat. That's very important, because when you want to subscribe some drugs, you have to count on that which drug is dissolved in water or dissolved in lipid, because the distribution will be different one. You know that in a newborn baby, usually they do have much more water than fat, and this will change by age. Decrease the circulation. This is why the adaptation to any kind of stress or any kind of extra cardiac output, it's more difficult to do with an elderly one. Immune system is failing. Immune system. Usually the cellular immune system is deteriorated. This is why this patient usually can suffer from fungal infection, bacterial infection. But the humoral immune system usually is more maintained, or maybe it's overshoot. This is why this patient can have autoimmune reaction, autoimmune diseases. Neuronal loss or myofibril loss, cartilage loss, that will influence, of course, the joint, influence the movement, influences the sensation. And they pronounce to fall, for example, very easily. And the limited fibroblast application, this is why the connective tissue, the elasticity decreases, and usually the fibrosis can occur very easily. Hearing problems. In elderly one, very easily and very frequently, you can sense this tinnitus. That means ringing or a very high voice of the noise that they can hear all the time. And another very, for example, important one, the limited ability to pick the speech from a noisy environment. So they're very difficult to distinguish. Okay, you are talking in a very crowded area. You have to discriminate your partner's voice from a surrounding, the background noise. And in elderly one, it's very difficult to do that one. So this is why they cannot hear as well in a normal one. Visual problem. Macular degeneration and cataract is more common one in elderly patients. Taste. This is why the elderly usually they put more salt or more sugar into the drink, for example, because the ability to lose the taste, this bonds expect sugar and okay. Smell, loss of olfactory stimulation, and you can maintain it if you start to stimulate. Bones. In the previous semester we discussed the amount of calcium is decreases by age, and in elderly one the 1 or 2% mineral loss occurs usually after 65, but you can maintain if you exercise or if you use some kind of medication. Muscle. The muscle amount, the cells, usually decreases very similarly than another organ, and if you, let's say, start exercising, the volume can expand, and this way can replace the lost tissues. Reflexes, slowed by age, very nicely. Balance. The patient, they're not sensing, let's say, that the balance, and this is why they are more pronounced to fall. And if you see that, for example, 40% of the elderly one falls, and because they do have less bone mass, this is why it's very easily they have suffering from fracture. And cognition. Decrease in a short-term memory. This is why the elderly people usually doesn't remember what happened, let's say, 1 hour ago or maybe 15 minutes ago, but they can remember what happened about 40 or 50 or 60 years ago very nicely, and they can recall old stories. But this cognition usually affected by diseases, for example, hypertension or diabetes. Learning, another important one. You will sense it now. You feel that you can learn almost everything, especially during the exam period. If you do leave, for example, 10 days for a project, you can learn it by heart. There's no problem with that. But when you start to age, you will recognize that it's more difficult to do that one. Another very important one, the visual way to learn is somehow altered. But if you want to learn by hearing, that's more maintained. So you can combine the learning process, for example, if you start listening and reading together, maybe that's an easier way. Now, they learn slower than an average population. However, whatever they learn, they can use it much better way because they can combine, and they do have a much wider aspect and connection between these stories. Depression usually is very highly influences the elderly one because usually they left alone, and this is one thing. Another one, because the brain circulation is altered, this can influence the neurotransmission, and the depression is very common one in elderly one. Dementia. Usually that's, if you look at the age, the percentage of the patient who has dementia is about 2 to 3% at the age of 65 and 70, but over 85, it's more than 50%, and this is what will happen in very fast progressing one by age. Now, the sexual activity. Well, everybody thinks that, okay, why we're talking about that. Usually the people keep the sexual activity, especially men. If you look at by age of 70, about 65% of the guy, they do have, let's say, a regular sexual activity, and comparing to the women, that they have a 30%, it decreases by 9. I know this looks like it's a stigma to talk about, but you will be aged, so don't worry, you will be an old one. And but now you are thinking about the sex for the young one only, and this is why this old one is this thing with, but the old people usually interested and they are leechers. But the men, of course, they are much better way because now they are supermen. Now, if you summarize, let's see the different pathologic conditions in elderly one, that is a balding, for example, or senile dementia, deafness, loss of teeth, very common one, or dermal elastosis, when the elasticity decreases, hypertension and ischemic heart diseases, osteoporosis that influences, let's say, the bone structure, prostatic hyperplasia in man, or degeneration of the joints, or diverticular diseases of the colon, and more commonly, usually cancer can develop. Edema, for example, due to the heart problem. So these are the aspects that usually influences the patient. If you look at the brain, for example, this brain, that is a normal one, and this is a senile one, or Alzheimer disease, you do see the fissures are very large one and opening up in the patient. Now, aging, it looks like is a progressive time-related loss of the structural and the functional capacity of the cells, and this will lead to the death. Now, this aging process usually is, and it has to be located some kind of cellular level. So the cells, as you age, this is how the whole organ starts to age. And this aging process usually precedes by the blood vessels damage that supplies the nutrition to the blood. Let's see the different cell structure, how is influenced by aging process. If you look at the structural changes, for example, the plasma membrane. The plasma membrane permeability increases. Relatively, we do have less fluid and increases in the saturated fat. This is why the membrane be more rigid, because it's more rigid that, let's see, the receptors and other protein cannot flow as fast as the younger one, and this is why it's influenced, let's say, the response of the cells to the different stimuli. Nuclear changes. The chromatin that usually when we are young one, of course we have to multiply, usually they are unrounded, they are lighter one, but in elderly one they are more condensed because they are more round, and these chromatin usually they have a cross-link, that the cross-link is increased more in elderly patient. And this means that when you do have any kind of DNA damage, this DNA damage cannot be, let's see, corrected so easily because this enzyme machinery cannot reach the area. Lymphocytes, for example, very important one, they did a study, they put lymphocytes in culture, and when the lymphocytes started to age and they realized that the chromatin got more dense and the correction couldn't be done so easily, and usually after maybe 40 or 30 replication, usually the cells will die, unless they transfer to, let's see, the malignant cell line and they will proliferate forever. But what they did, they put some reducing agent into the medium that break the disulfide bonds, and this cell starts to, let's see, proliferate faster. So it looks like you can alter or you can interfere with this DNA repairing mechanism, and you can interfere the intracellular processes. Another thing that you maybe already heard, that the cytoplasmic changes. First of all, the volume, it will increase by age, so the cells getting a little bit larger by age, and the cells, those debris that they cannot metabolize, that cannot expel from the cells, they stay inside the cytoplasm, and this is called the lipofuscin granules that accumulates inside the cells, and especially in the non-dividing cells, for example, the nerve and the muscle cells, and the amount of this waste product is correlated by age. There is a disease when they do have the problem with the degradation of the lipofuscin, and in young one, in very young, for example, 4 years or 5 years, they already do have some kind of organ damage due to the accumulation of this waste product inside the cells. Ribosomal changes. The RNA decreases with age, and this means that the protein synthesis decreases. So this is why the elderly one cannot increase the protein synthesis that needed, for example, for the metabolism, for the other enzymes and other cell function. Mitochondrium. Now that's a very interesting one. First of all, because the whole mitochondrium is heredited from our mother. This is only one organ that is not coupled with your father and mother. Only we are getting from our mother. And the mitochondrium is very important because mitochondrium generates the ATP. So mitochondrium will maintain the energy, so this is the gasoline for you that you can work with. And it looks like, as I'm talking about later a little bit, that the aging process is more close to, let's see, to your X chromosome than your Y chromosome. So it looks like it's a mother heredited things, how long can you live. Now, if you look at how the mitochondrium is aged, usually the crystals, the folder, is getting less and less, and the numbers of the mitochondrium is getting less inside the body. This can be seen. Liposomes. The lysosomal activity decreases. This is why the lipofuscin amount, it increases. This is the cellular garbage increases inside the cytoplasm. And the enzyme that can release out from the lysosome can damage the tissues and can cause, let's say, a further acceleration of the damage of the cells. Now, you learned about the apoptosis and necrosis. The apoptosis usually is an internal cause that there's a cellular suicide, and trauma usually occurs from the external source and randomly break the DNA. Now, apoptosis, that naturally and developmental process, usually this is how the cells can be renewed, because you have to remove those, let's say, old cells or used cells. Now, what will affect the aging process? Of course, everybody knows that somehow the genetic. Now, the genetic almost takes about only 60% of the cases. Of course, if your parents lived or grandparents lived for 100 years or 120 years, you have a higher chance that you can live, let's say, relatively longer life. But as you see that the environmental factor is about 40%. This is what we can do about it, because we cannot do anything about the genetics. Now, based on the genetic, we said that, okay, we do have some kind of Clark genes. I shall talk about that in fibroblast culture. They proved it. And we know that there are some diseases, genetic diseases, when this aging process is accelerated, and a newborn baby, or maybe a few years old baby, can look like a 70 years old baby, or a man. And this syndrome, for example, there are several syndromes. One syndrome is a Werner syndrome, when we do have a mutation of the DNA, it is a DNA helicase, and this means that telomerase, we shall talk about the telomerase at first later, because every division usually shortening the DNA structure. And in Werner syndrome, this process is accelerated, so the cells are aging much faster. Another is Cockayne syndrome, and this again influences the DNA repair mechanism, or Xeroderma pigmentosa, again is another one that usually manifested as an increased aging process, and this again has a problem with the DNA repairing mechanism. Now, the aging gene that we figure out from these diseases is located in chromosome 1. And, as I said, the aging is a female pattern, follows the female pattern. And this is why the mitochondrium, we think that because the mitochondrium is heredited from the mother. Now let's talk about the Progeria syndrome, is one of these syndromes. And this Progeria syndrome, it's extremely rare. extremely rare diseases. If you count, it's 1 out of, let's say, 8 million people that is affected by progeria, but there are some on the world, and I'll show you some picture of it. Now, usually it looks like it's a very young one, but the aging process is accelerated, and the patient has the same symptoms as we discussed, the hearing problem, the joint problem, the muscular problem, the kidney problem, that all organs are affected very similarly. There's a normal aging process. This is an autosomal dominant hereditary disease, but usually this influences by point mutation this L1 gene on the chromosome 1. I don't want to talk about, and this will influence and this will increase the aging process. There is no cure for these diseases. Usually this patient will die of an age of 10 or 13, so it's very early in age. Now this is how they look like. These are the baby when it's born. This looks like as maybe 40 years or 50 years. And usually this disease is not heredited as much because they cannot mate, because when they reach, let's say, the age of 14 or 13, they will die. So there's no way that they do have a sexual, let's say, activity or they can mate. However, the point mutation is the problem when they completely normally, let's say, parents, they figure out that, oops, the baby has these diseases. So this is what can happen. It's a very rare form that is heredited one. I shall show you that one as well.
Hi, my name is Ashley. I am 14 years old. I go to Coalhurst High School. I am going into grade 9 in the fall. I like to ride my quad. I love animals and I volunteer at the pet hospital. I really like to watch movies and eat popcorn with my friends. I have a baby brother. He just turned 1 on Canada Day. I love it being a big sister. I love to go camping in the summer. I also sleep outside in my tent. I can't wait for hockey to start again. If you are like me and have progeria, I would like to share some things with you that have helped me. When somebody stares at you, don't let it bother you because maybe they don't know about progeria. You can tell those people about progeria. Maybe they'll understand. And if they don't, it's okay. You're one of a kind. You know the truth. When I have chest pain, I take my mind off it by doing stuff. Or sometimes I use oxygen. I used to snore and have bad sleeps. But now I use nose strips called Breathe Right, and they really help me sleep. I wake up refreshed. Don't keep my family awake.
Thank you, Ma.
The disease is most advanced in the 2 eldest children in the family, 19-year-old Rahana and 17-year-old Ikramul. But they know precious little about what is happening to them.
This disease is called progeria, and it is to do with genes. This is all we know. I don't know anymore.
Progeria is normally caused by a random extraordinary defect. Usually, if you have one child with progeria, you are no more likely to have a second affected child. So the most puzzling thing about the Indian family is that all but 2 of their children have been struck by this disease.
The family is a unique experiment of nature. That sounds very strange, but it extremely rarely happens that you have so many family members who are affected.
Maybe Saruman too.
Progeria children die on average at 13, but some have survived into their late 20s. As there is no scientific precedent for the children's disease, the doctors are in the dark about what to tell the family.
Since we've met Dr. Chamden, we've had many happy times.
7-year-old Ali is the youngest child suffering from progeria.
When I grow up, I want to be a soldier. My father was in the military. They go left, right, left, right.
Ali is a rascal. He can't stop running around. He's very stubborn and he keeps running away.
At 17 years old, Ali's big brother Ikramul is the eldest boy in the family.
Ikramul is a man. His voice is deepened. When the other children hear him, they know there's a man in the house who's talking.
I can make everything with my hands. Whatever I see, I understand. This should be done. This and this don't go together. See that speaker up there? I made it myself. If I felt better, then I'd earn more money, and I could fulfill my wishes. The one thing I would like would be to buy a cell phone.
Whenever the family go out in public, they attract considerable attention.
There's an absolute circus when I take the children out. People stare. The whole world gathers.
Although Rahana's body has been ravaged by this disease, her mind is unaffected. She has the same interests and desires as any other teenage girl.
I like to wear nice clothes, and I like wearing lipstick and some powder. I want to go out with other girls and to buy things myself.
14-year-old Sanjita is one of the 2 children in the family who are unaffected. Tragically, she is likely to outlive her 2 brothers and her big sister, Rahana.
Rahana likes being fussed over. She's very happy then. She likes putting on lipstick and makeup and looking pretty. She loves all that. She enjoys making us laugh. If she doesn't laugh, I don't feel like laughing.
For many years, the Khan family had lived under the shadow of progeria. When Chandan discovered the family, they were all badly malnourished, and one child had already died of the disease. He rushed the others to this hospital.
Rubina had a cough and asthma, and we were both admitted to the hospital. My asthma was even worse than hers, but she was very weak. She weighed just 5 kilos.
She looked as if she was improving a little bit. She was really very sick. She needed oxygen. They started resuscitation, and when I came about 3-4 minutes later, things were already over. We couldn't do much anymore, and somehow you feel stupid. You have the whole medical setting, you know your limitations, and oh, they came here in order to be better, but one of them dies.
Rubina died on the 25th of March, 2003. She was only 10 years old.
For almost a year, I was depressed. Sometimes when I slept, it seemed that she came and stood in front of me. For almost a year that happened whenever I closed my eyes.
American Ori Barnett is 9 years old.
What'd you get?
Ori had a stroke when he was just 5.
He did have a stroke in 2001. The doctor decided to put him on a blood thinner. I just have to watch him so he doesn't get bumped or cut or fall down or hurt himself, because it could be hard to stop the bleeding.
Since his birth, Ori has developed all the other symptoms of classical progeria.
He has very tight skin, so that can limit his range of movement. It's very thin, so if he gets bumped, he can get a black and blue mark really quick. He has very little hair.
Sticky square. Blue, please.
But his voice is kind of high-pitched.
How to get another one?
I know. He's just started losing his teeth, and I hope that that's not going to be a problem, because he doesn't like the dentist. Click your button. You're good.
I can't see it.
Ori is still too young to grasp what this disease is doing to him.
He's going to wonder sooner or later why he goes to doctors and why he does look different, and why if we go to the store or someplace, people stare at him.
Bound to destroy Caribbean ship.
We'll figure it out. Cool.
Now, we should talk about the environmental factor, that we can do something about it. You cannot do anything about the genetic, but you can do something about the environmental factor. Trauma. If you're suffering from a repeated trauma, you are aging faster. If diseases, for example, certain diseases associated with the aging process, such as atherosclerosis or diabetes, it's well known. Diet, malnutrition, obesity, a lot of things can influence the aging process. Or the surrounding one, the stress, is very important, that can influence your aging process. If you are happy, you are aging less than when you are sad or you do have the exam periods come. Now, let's see what are these theories that we can explain, or we try to explain the mechanism, how this aging is going on. Because if you know it, you can interfere with that one, and you can somehow at least not reducing or not extending your ages. But if you can reduce the number of diseases that are associated with the aging process, that's another good things with it. Now, these three categories of the theories, usually they say that the aging should be affecting the all individuals of the population. And the process that this does have, change in function and structure that influences the cells, influences the organs. And these changes is associated with age, so it's progressively going on and progressively going ahead. Now there are three major theories that we are going to discuss. One is the wear and tear, or the damage theory. Another one, the physical chemical changes theory that occurs by aging. And another one is a program theory, the genetically programmed theory. Now, usually we are asking, why do we age? This usually everybody asks, why do we age? But I think we are asking the wrong question. Why don't we die, let's see, earlier? Because none of them, let's see, the wild animal, they won't age. They will die when they cannot meet with the surrounding expectation. And this is why in 70s or 80s, let's say 100 years ago or 150 years ago, the humanity, the age, a lifespan of the humanity wasn't longer than 35 or 40. Because that age is enough to disperse your genetic. You have your child, the child already grown up, and you are not needed. So only the domestic animal will age if you keep them in a, let's see, the more protected area. And very commonly the humans. Now we do have a, let's see, almost ad libitum access for every food, everything, and we have the high health care, and we don't need to fight against, let's see, the predator. So this is why we can age. Now if we lived in a jungle, I don't think that we can run, let's see, or escape from predators. This is how we don't have this problem by aging. And of course we would have less diseases as well. Now, this theory, the first theory that I'm talking, this wear and tear theory, that says that if you damage yourself, let's say, too much, you will live shorter. Very similarly when you buy a car. When you buy a car, of course, this car can be used, for example, for 20 years or 30 years, as long relatively as you live. However, if you start driving your car, or maybe you are, let's say, a race driver, of course, you cannot use the car longer than maybe half year, or maybe only one race, that's it. So, you can damage yourself very easily. This is what they said. And if you do have these insults and injury more frequently, this is how you will influence a lot of things. For example, if you lose your teeth, you cannot eat as much. That will influence your body, that will influence everything. At the molecular level, when this damage that affecting free radicals, anything that affecting the enzymes, and these harmful products that is accumulated, for example, aldehyde, the free radicals, lipofuscin and other, that can influence the aging process, can influence at the cellular level, and more cellular level will influence the organs and influence the whole body. Now, this theory says that, this is an experiment they did. For example, animals with high metabolic rates have shorter lifespan. For example, they're still examining clinically, because looks like the heart rate and the lifespan is irreversibly correlated to each other. Those animals that do have a higher heart rate, for example, the colibris or birds and other, they don't live as long as the, let's say, the slower heart rate animals. And it looks like in human, they do have very similar, let's say, expectation. If somebody does have, for example, a higher heart rate, usually the lifespan of those people, let's say the humans, are shorter one. Now, if it's possible, it's very easy to say that, okay, when you use beta blocker, we can slow down the heart rate, so this way the patient can live longer. But maybe it's not true, maybe 1 or 2 years, but it's very difficult to examine. Now, they did an experiment, for example, the calorie-restricting diet. In those rats that they were not fed, let's say, ad libitum with food, only they had about 10% or 20% restriction of the energy intake, those animals live longer. Because when you oxidize, when you produce it, when you metabolize, let's say, the product, you are forming some toxic product. And this toxic product can influence, let's say, the function of the cells. Now, another one. This is genetic evidence. Usually what they said is a reformulation of the failure repair theories. What they said that, okay, later on, if we do have some damage inside the cells that cannot be repaired, and this product, when it's left inside the cells, that can cause the problem, and this is a time-dependent changes. Now, for example, the physical-chemical changes, what they said that, as we said, cross-link theory. That cross-link theory can influence the protein, can influence, let's see, the DNA, can influence other molecules that they do have some important role inside our body. Now, for example, macromolecules, collagen or elastin, when they do have the cross-link, they be more rigid one, or the protein. And they do find an important correlation between the disulfide bonds and advanced glycosylation end product and a disease that's happening in diabetes. In a diabetic patient, every organ deteriorated much faster than the normal one. So there are some intracellular mechanism that looks like by diseases or some other environmental factor that can influence this. Alter protein theory. They said that, all right, because the primary structure may be influenced, and this is why the catalytic function of different protein, for example, enzyme is influenced, and this is why we do have some problem. Or increased carbonyl content, for example, ketones and aldehydes, or that will oxidize, for example, the protein, that can occur in an aging process. Free radical theory. Now that's a very well expected theory, the free radical theory, when we do have an oxidative damage that influences the DNA, influences, let's see, the protein, and of course, because we are living in an open air, we are in an aerobic condition, there's a very high chance that as we live, we're using up, let's say, more oxygen, we're producing more free radicals, and we're damaging more proteins, and this will promote, or this will accelerate, or this will drive the aging process in our body. For example, lipid peroxidation. The lipid peroxidation influences the membrane, influences the fluidity of the membrane, and influences, let's say, the intracellular mechanism and the signal transduction very easily. And this protein cross linkage or DNA damage can be. And they try to use, for example, antioxidants. There are some very famous people, for example, Sanjari, who took about 6 grams of vitamin C every day. Of course, vitamin C can cause kidney stones, but he didn't get kidney stones. But there's no way that you can slow down or you can do something with this aging process. But this is one possibility of the aging that we have. Now, this free radical theory, what they said that because we are an aerobic metabolism that produced by mitochondria, peroxisomes and everything, that these free radicals, relatively, that will alter the anti-oxidized capability of the body, because the free radicals usually is cleaved by enzyme system. And if this decreases, you do have more than these free radicals can cross-react with other molecules, and these other molecules can further deteriorate the other macromolecules, DNA, RNA, protein, and lipid. And these oxidized macromolecules, that some of them can be repaired, but some of them cannot be repaired because irreversibly is damaged, and that can accelerate the cellular damage. So there are certain way. Another one that we already said, that the problem with, let's say, that about 60% of the cases is heredited. So somehow it should be connected to the gene, and some kind of biological clock should be inside the body. And this is why, because when they use these twin studies, the two twins lives about the same age, so about the same long. Now, where is this biological clock is located? First, they started with the hypothalamus. Maybe the hypothalamus that orchestrates the whole endocrine function. Maybe that's one. And when they decline in signal and decreases the sensitivity of the feedback, this is why the whole thing is fastered up and speed up. And there are some other data came when they used the cell culture evidence. The cell culture evidence showed that from different species and from different lifespan, the cultured cells lived differently. Some cells, for example, they obtained, for example, a turtle. You know that a turtle can live about almost 200 years. They could divide in culture about 90 to 125 times. And if you compare to the mouse that lives about 3 years, that can divide only 18 or 20s. So it looks like between the age of the lifespan of the species and the number of the cellular divisions somehow is correlated to each other. Now, they did have another experiment. When they got out, for example, some cells for a newborn baby, they could have, let's say, a population doubling time about 65, 70 or so. When they got out the cells from a Werner's patient, a progeria that we were talking about, these cells could not divide as let's say, as many times. They could divide only 30, 35 times. And when they got out, let's say, some cells, some fibroblasts, from an old, let's say, patient, from a 100-year-old patient, again, they had less division. So it looks like inside the cells knows how old they are and how many times they can replicate. This is why they introduced this new, let's say, process that's called the telomere or telomerase process. Now, you already heard about this telomeres, telomerases. Let's refresh what you learned.
The ends of linear chromosomes pose unique problems during DNA replication. Because DNA polymerases can only elongate from a free 3' hydroxyl group, the replication machinery builds the lagging strand by a backstitching mechanism. RNA primers provide 3' hydroxyl groups at regular intervals along the lagging strand template. Whereas the leading strand elongates continuously in the 5' to 3' direction all the way to the end of the template, the lagging strand stops short of the end. Even if a final RNA primer were built at the very end of the chromosome, the lagging strand still would not be complete. The final primer would provide a 3' hydroxyl group to synthesize DNA, but the primers would later need to be removed. The 3' hydroxyl groups on adjacent DNA fragments provide starting places for replacing the RNA with DNA. However, at the end of the chromosome, there is no 3' hydroxyl group available to prime DNA synthesis. Because of this inability to replicate the ends, chromosomes would progressively shorten during each replication cycle. This end replication problem is solved by the enzyme telomerase. The ends of chromosomes contain a G-rich series of repeats, called a telomere. Telomerase recognizes the tip of an existing repeat sequence. Using an RNA template within the enzyme, telomerase elongates the parental strand in the 5' to 3' direction, and adds additional repeats as it moves down the parental strand. The lagging strand is then completed by DNA polymerase alpha, which carries a DNA primase as one of its subunits. In this way, the original information at the ends of linear chromosomes is completely copied in the new DNA.
with a telomere or a telomerase can explain why different cells can live longer or shorter, or can divide less or more. There are some cells, different cells in our body, some somatic cells, for example, they do not have the telomerase enzyme that can elongate the telomere that cleaved out with the DNA replication. However, the germ cells or the hemopoietic cells, they do have this enzyme. So relatively, your, for example, ovaries or testes, they can live as long as you wish, or the stem cells can live as long as you wish. However, the somatic cells, the heart cells or muscle cells or kidneys and other cells, they cannot. And this is why they are getting older and older. Now, they did an experiment and they proved it because, for example, these are the germ cells and stem cells that can live as long as you supply with nutrition. The lymphocytes that usually declining a little bit less slope, but the somatic cells usually loses the capability for division, and they do have let's see, a limit, a crisis limit, and this was a Hayflick limit when the cells could not divide so many times, and especially when they transform or not. If they transform, there's be a tumoric cells. But what they did some infection when they infected the cells or transfected the cells with telomerase enzyme, and after they started to, let's see, proliferate almost incontinuously. Now, the gene mutation theory, that's another theory that is still in business, let's see. They said that the gene mutation, that accumulation of somatic cell mutation leads to decline in function. For example, liver cells of older mice have more mutation than a young one. So it looks like the mutation is very, very important. And if a short lifespan strain, relatively, they accumulate more mutation than another one. So it looks like the repair mechanism, DNA repair mechanism, is important in this aspect as well. Now, this kind of gene theory usually is examined by microRNA analysis, and they define some genes that is correlated with the amount of extra DNA crosslinks or DNA alteration. Now, these are the theories. Out of these theories, the most accepted one, the telomerase theory and the free radical theory. They say that the telomerase theory gives you the genetic hereditance, and the survival or the environmental factor is influenced by the free radicals. So if you can reduce the free radicals, you can live relatively longer, or you can live that life that is already coded in your cells. Now, however, as a physician, what you should do with the elderly patient, because usually you will treat the elderly one. Very importantly, this aging process relatively influences the clinical signs of diseases. So, for example, a new disease could have completely different signs in elderly one. For example, let's have a very simple one, the hyperthyroidism. You know what the clinical sign of hyperthyroidism, tachycardia, sweating, or heat intolerance, losing weight, tremor, etc., etc. And elderly people usually doesn't come with these symptoms. They could come with a problem with the heart. They can suffer of heart failure. And they are taken to the hospital due to myocardial infarction or heart failure. Because this thyroid, the increased level of the thyroid hormone, that causes an increase of the cardiac output, that causes, let's see, a relatively increased workload for the heart, and because the cardiovascular structure is completely influenced in the elderly one, they could not get enough nutrition. This is why infarction can be the first sign. Very similarly to anemia. Normally anemia, that is pale, maybe tachycardia, etc. But in elderly one can be called ischemia, or the sign myocardial infarction, or angina, for example. This is how it's presented. Now, another one, maybe it looks a little bit more weird, that easier to cure and a better response to the therapies. Well, why? Young one, because the young one can, let's see, accommodate to the changed environment. So they are using up the reserve function that they do have. If the young one getting sick means they lost the capability to accommodate to these changes. So the young one, if they go to the doctor, they are really sick. Because they do have the whole problem that occurred from the diseases, and this only presented if they used up, let's say, to accommodation capability. An elderly one, let's say, because they don't have a nice reverse function, if altered something, they could present immediately a disease. And if you start curing it, maybe you are not curing the underlying problem, but you are helping to accommodate to the diseases, and the patient feels much better right away. So, another thing, the drug. Drug side effect is more common one in elderly, because the metabolism of the drug or the distribution of the drug is different in elderly one. And because, again, very similarly, they cannot accommodate to this, let's see, toxicity of the drugs, so they can present right away a clinical sign or symptoms. So, now, another thing, whatever is abnormal in the young one, maybe is not the clinical, let's say, meaning of in an elderly one. For example, bacteriuria. You will learn in pediatrics that if somebody suffers of any kind of fever as a young one, you have to think about maybe upper airways infection or urinary tract infection. These are two common things that can cause fever. In elderly, bacteriuria, it can be asymptomatic because the closure, let's say, on the sphincters are different, and they do have always a little left over for the urine, and maybe diabetic one, they always have some bacteria grows in. And this way, this bacteria doesn't cause any symptoms because they are living with this bacteria. So you should not be happy if you do find, for example, bacteria in an elderly patient, because it could mean only an asymptomatic one. And you have to search further to the cause of the fever. So you should not stop by only saying that maybe, let's say, bacteriuria is that one. Now, as the difficult to find the right diagnosis because the clinical signs are more complex on the elderly one. If you think about, yes, it's true, because if something is altered, let's say the accommodation capability, the locus minoris, that be the first one that be presenting. Maybe it's not the underlying problem. And this is because elderly patients suffer more from the side effect. If you improve, the patient relatively be better and easy way, and this is why you be a good doctor for an elderly one.